Welcome guys, I'm going to have you do an activity today with the sub that's going to show you about geometric constraints. So you should find this link in Schoology. I'm in the Q1 folder at the very top, geometric constraints. I'm going to click on it. You guys will see a submit button. Okay, I'm going to see submissions on my end. You guys are going to, the big picture is you're going to download an inventor drawing file. Okay, we'll do that here in a second. We're going to watch a video that's going to guide us through manipulating this drawing file to learn about the geometric constraints. Afterwards, I'm going to adjust the zoom so I can see the whole drawing sheet, and I'm going to take a snip of it so I have a copy of a picture. Okay, I'll have my inventor file, but I also have just a picture of the page I created. That picture is what is going to get submitted. So it says submit a snip. So you'll have to use the snipping tool. You can go to your Windows Start button and type in snip. If you don't have it pinned to your taskbar, you can right click on it and choose pin from taskbar. Mine says unpin since it's already pinned. That tool, if you've never used it, it's very simple. You just click, hold, and drag, and whatever's in the box is a picture. You'll hit save. Save it to a location that makes sense. Give it a name that makes sense, like, perhaps geometric constraints, and your last name. Okay, so give it a name that makes sense, store it in a file that makes sense, or a folder, hit save. You then have a copy that you can hit submit and upload. Okay, so here's what it's going to look like. We're going to click on this link right here, and I can even right click on it and say open a new tab so that this page I'm on will stay here, because I'm going to want to come back and open that YouTube video, right? So open link in new tab, and it creates another link you have to click on again, but now it's going to download it. So I click on it, it downloads. Remember down here in Chrome, I can see that a file downloaded. I hit the little up arrow and say show in folder, and it's going to take me right to I should be in downloads right now. It's in my downloads folder, and I have downloaded it before, so it's already in here. I'm going to grab it. I'm not going to open it right now, so I did not double click. I'm going to have just selected it. I'm going to hit Control X, and then I would go to Documents, and this is just to mimic what I've shown you guys to do, to have on my IED files. So I would go in there, I would go into my inventor projects, and if you created just kind of an inventor practice folder, so like miscellaneous practice stuff, I'd put this in here. So I'm going to now Control V to paste, and there you go. So now I know where it is, and I already have inventor launched. You can open by going and navigating to it, or you could have double clicked on it in the folder. But this is another way to get to your files, is from inside Inventor and choosing open, and you can go in and find it right here. Okay, so we've got the file open. I'm going to walk you through this at this point, and then remember at the end we're going to snip it. We'll have our name on it as well. We'll snip it and upload it. Okay, first off, just let me make a note that this is not a part file. We're not modeling a part. We are in a drawing file. However, the things that we're going to use in this drawing file, we can do also while we're sketching inside a part file. If we're trying to create a sketch using geometry to kind of define our profiles, these tools that are available to us here, even though I'm in an IDW, a drawing file, are going to be available to you when you're inside a part file. So a sketch was created on a drawing sheet, and I'd like to go and work on that sketch. I want to edit it. So I'm going to go to my browser, find the sketch, I'm going to right click on it, and I'm going to say edit. This just looks like when I'm in a part file and I'm drawing my sketches, right? My line tool, my circle, my arcs, my rectangles, fillets, all these things. So one of the things that you may or may not have noticed is that you have a panel called the Constrain Panel. And the dimension tool you've probably used is part of that. That's like a numerical constraint. It's constraining how long something is, or a distance. But we also have geometric relationships that we want to walk you through how to use. So I'm going to zoom in and kind of do them one at a time. The first little one, it says make perpendicular. Perpendicular means that these two lines are going to intersect at a 90-degree angle. Up in my Constrain menu, there is a tool. This one's not upside down, it's like slanted too, but it kind of looks like an upside down T to me. So that is the perpendicular constraint. If I select it, then Inventor even down here is going to guide you through what are the things you need to select. It says select first a line or an ellipse axis. An axis would be a line, kind of referencing. So I'm going to choose this line segment. And then it says select a second line. So I'm going to choose the second one. And then notice that I get that little upside down T logo, kind of letting me know that that's a right angle. And if I really wanted to check it, I could go back and dimension this. If I choose two lines that are not kind of parallel, it's going to let me measure the angle between them. So there you go, 90 degrees. That's what I wanted. And this says adding the dimension will over-constrain the sketch. Yeah, because usually the dimension tool is used to kind of create a relationship, but the relationship's already created. It's already perpendicular. So this is just saying, hey, it's going to be over-constrained. You don't need this. Or you can go ahead and accept it to create a driven dimension, which means the dimension will show up, but it's not that the dimension's creating the relationship as much as just kind of showing one. So a driven dimension is going to have parentheses around it. So that's another little thing you can learn. All right, so move on. That's the perpendicular tool. This one says make all three lines parallel to each other. Notice my dimension tool is still on, so I'm going to hit escape a couple times to turn it off and kind of reset things. And make all three lines parallel. There is a parallel tool up here as well. So this is the parallel constraint right next to perpendicular. So I'm going to choose it, and I have to choose two lines that I want to be parallel. So it says select the first line, select, choose the second, select. Now it created that relationship and it's basically reset. The tool is still on. I can use it again, but I can't just select this and have it snap to all three. Okay, it's like starting all over saying, okay, this is one line, but what's another line that you would like to make parallel? So I have to now make a second selection for this set. Okay, and for some reason, just the way it moved and became parallel, it jumped over there. I'm going to hit escape to turn the tool off. And now I could grab and kind of move these lines around if I want. So there you go. I can try to move them. Let's see. Some of them are kind of the independents and some are the dependents. Here you go. So this one's the independent I grabbed. It's the one that's allowed to move. The others are going to depend on this one. So if I grab that point and move it, you notice that the other ones are going with it. Okay? So that's kind of cool. All right, this says dimension number 3 to diameter 2. I think fixture's going to make tangent 212. I'm trying to remember. I think they wanted us to make circle number 3 have the same diameter. So there is an equal constraint I can use. Let's try choosing 3 first. Okay, so the order that I had to remember and see if that mattered. I assumed it did. The order that I select these in controls which one's going to change. Notice if I select 2 first and then 3, 2 adjusted. I'm hitting Control Z on my keyboard, or you can hit undo. Or if I choose 3 first and then 2, 3 adjusted. So dimension 3 to circle 2's diameter. So now they're equal. And I see that little equal logo. Those logos that show up, I can make them appear using the F8 tool. F8 tool makes your constraints visible, little symbols to show. You can hover over the symbol, and then the geometry will highlight. That's relevant. So the 2 circles became red, notice. So those 2 circles are equal. If I want to hide those, I can hit F9. So F8 to show, F9 to hide. Okay, so it says fix circles 1 and 2. That means I don't want them to move. Right now, circle you can locate by its center, which means I can grab the center and move it by its center. Okay, so they're movable. So we want them to be fixed so that they can't move. So I'm going to kind of keep them generally where they were, but that's fine. To lock something in place, there is a lock tool. That'll fix its location in space. So I'm going to use the lock tool, and I'm going to lock that center point so it can't move. And then I will, the tool's still on, use it again on this one. I'm going to hit the escape key to turn that tool off. And then I'm going to try to grab that center and move it. And notice that I'm clicking and holding, and it won't move. Okay, there's that logo. It's kind of even bringing it up saying, hey, this guy's locked. All right, so now that these are locked, these cannot move. And it wants us to make circle 3 tangent to 1 and 2. All right, tangent is when two things skim and touch each other at exactly 1 point. This would not be tangent, as the circle overlaps circle 1 twice. This is not tangent, they don't intersect. Tangent's basically when they just kind of kiss at exactly 1 point. So, zooming in, they're missed. But basically it'd be kind of perfect. All right? So there is a tool that will do that, and it is right here. This is the tangent tool. So if we choose that, we're going to have to make 2 selections. I know the symbol shows being tangent a line and a circle, but it could be 2 curves. It could be a curve and a line. So I'm going to choose circle 3 to be tangent to circle 1. Okay? And now the tool is still on. I'm going to use it again to make circle 3 be tangent to circle 2. So circle 3 is going to move into position. Let's hit escape though. Right before I do that, notice that circle 3, let's maybe lock the diameter of 1. Whatever it is, I'll just accept it. Okay, so that basically circle 1 is fixed. And let's kind of lock dimension 2 here as well. Okay, so circle 1 is like this fixed circle, and circle 3 is tangent to it. So all it can do is kind of roll around the outside. It has to touch in exactly 1 point. Okay, but where is that point that it would be exactly in place that it's tangent to both circle 1 and circle 2? It'd be like right here, but you know, that'd be hard to get it exact. So if we want it exact, we can use this tool. Circle 3 has to be congruent to circle 2, and now circle 3 can't move. Okay, it's kind of stuck in place, right? So before it was constrained to where it had to roll around circle 1, but now it's got to be tangent to circle 2 as well. And it's just stuck there. There's actually another location. If I undo that move, let's hit undo again. There you go. Since it can roll all the way around, it potentially could have been on this side. And I bet if that's where I wanted it, if I get it close to that position before I apply that tool, that's the location it'll move into. That's the other option. Okay, so there you go. This says make circle tangent to both lines. So now that we've used the tangent tool, this should be easy. Circle to that line, and then circle to this line. We got it. If you want to make the circle smaller, you can try grabbing the circle itself and kind of bringing it in towards the point. Sometimes, though, just depends on where I grab and how I'm moving my mouse. It's kind of jumping around at me. So there you go. All right, this says fix point C. All right, so remember how to do that. I'm going to use the lock tool. Boom. Make endpoints A and B coincident with point C. You know what? I think I'm going to show you how to use the coincident constraint. We're going to use it a couple more times than they intended. So the coincident constraint will take a point and make it fall on top of and kind of line to another point. So I'm going to make this point, the center of the circle, be at point C. So they're kind of one and the same. So now our center of our circle is C. Okay? And then I think they wanted the endpoints of these lines. They just wanted to have them labeled. So I'm going to make this point, which is point A, be the endpoint of the line segment. Okay? And then I'm going to do the same thing with B here and here. So that's using the coincident constraint. But they're telling us make endpoints A and B, so endpoints of the segments, be coincident with point C. So we're going to use it again. So I have this point that's now going to move over to C. And then I'll repeat. B will also go to C. So all 3 points end up being at the same location. Oh, I hit Control Z. I meant to hit Escape. Turn off my tool. All right. This one says make circles concentric. Concentric means that they have a common center. Right now they don't have a common center. I have this circle that has its own center. That is the center of the big circle and that circle. So to do that, I could use the coincident constraint, okay, and choose those. But let's do another way. There's also this tool right here, which is the concentric constraint. And instead of choosing the points and making the points be at the same location, I'm simply going to choose the circles, and it's going to make them be concentric. So those two are concentric, and I'm starting all over. I've already used it one set. So now this one to either of these two. They both have the same center, either one. And now I have concentric circles. Okay, collinear is when the two lines, in this case line segments, basically are part of the same continuous line. In geometry, we say that a line goes on forever, right? These right here are line segments. So in order for them to be collinear, they basically have to be parallel to, but I'm not going to use the parallel tool. They would have to be not just parallel, but they'd have to be kind of in the exact same line, kind of like this, right? Well, there is a tool that does that, and it is this tool right here. It's the collinear constraint. So I'm going to choose that, and if you want two lines to be lined up with each other, you can choose one line and choose the next. And now they're collinear. Escape to turn it off. All right, in this case, we're going to make the lines horizontal. We're not going to use the parallel tool and keep them both parallel and adjust one. We're going to use this tool right here. This is the horizontal constraint. All I have to do is choose a line, and it becomes horizontal. I will tell you that when you're in a part file, you have to know that sometimes your view cube, you get yourself all disoriented, and what is defined as horizontal is going to be vertical because you've kind of spun your views around. So just be mindful of that. Sometimes you'll click on that and it won't go in the direction you thought. So you can always undo and then try the vertical constraint if you're in a part file. Okay. Down here, it says make these lines vertical. So you get the idea. We're going to use the vertical constraint, this one, and we're going to choose a line, choose another line, and choose the third. All three lines are now vertical. An equilateral triangle is a triangle with all equal sides. We're going to use the equal constraint. We're going to choose one, then the next. These two now have to be equal. But the third line doesn't have to be equal. So if I can grab a corner, let's see, kind of depends on which. There you go. You can see that these two are kind of staying equal with each other. All right, but this one's allowed to be shorter. We want this one to also have to be the same length. So it just needs to be equal to one of those, and then it'll really be equal to both. So I'm going to choose this one and then this one, and now I have an equilateral triangle. Last up, or what, two more. Make the circles the same size. You can use the equal constraint on circles as well. There you go. Or I could have used my dimension tool, made them the same size. This one says line up the centers of the circles on the same horizontal plane. Okay, without creating a line, I can use the horizontal tool with points instead of lines, and I can say I want a point to be horizontal to another point. Notice that even when I hover, I didn't click yet, I get this red dotted horizontal line. That kind of gives me an idea of what direction that went. If I had hit the vertical button, you can see that it's going to be vertical. So on that horizontal plane, I'd like to bring this line, and then I'd like to snap that one to these as well. Okay, I think the one I choose, I don't know, in that case it didn't seem like it was consistent in terms of which one I chose first. Like on the last set, I chose that first and the others moved to it, but before the first one I choose, that one moved. So, but at least it lines them up horizontal to each other. So there you go. All right, so here's how we're going to turn in your activity for the day. We're going to use the text tool. I'm going to put my name somewhere on the paper. You can put it real big across the middle. Oh, hang on. Actually, we want to do one more thing. I want to hit F9 or F8. See, F8. I want all these little symbols to show up. Okay. So F9 hides them, F8 it makes them appear. So please hit F8, make them appear. Zoom in so that it's as big as possible, taking up your whole window. You can even try using the zoom tool over here. If you turn that tool on, you click and hold, and then you move your mouse physically, not the wheel, but you slide your mouse up and down, and it zooms in and out, and it gives you a little more control than with your wheel when it would snap. Okay, and then when I'm done, hit escape. I'm going to use the text tool, and I'm going to put my name somewhere. Where I click will be the top left corner of my text box. So I'll put it right here, and I will put Mr. Orlando. And let's change the size. Let's make it bigger. 0.12 is going to be small. Let's go like 0.36. Okay. And if you even want it to stand out, you can double click and highlight it, and you can change the text color. I don't know, how about blue for cougars? There you go. And now we're going to use the snipping tool. We're going to click, hold, highlight, and get everything in frame that we want to be our picture. We're going to hit save. Save it to a location that makes sense. All right, so let's see, documents, my ID files, my projects. This is just Inventor Practice, and I'll call this Geometric Constraints, Snip, and I could do my last name again. Oop. Somehow there you go. Hit save. So now I know what it's called and where it's located. So I'm ready to go back to Schoology, and I'm going to upload. Okay, so I kept that, remember that tab open. So here I would hit the upload button. Okay, and when that happens, you're going to get a little icon. You're going to get a dialog box. It doesn't say this clearly, but there's a little dialog that is to go browse for a file. So it'll look something like this. If I were to add files to Schoology from my end, okay, I think you get not even attached files, but you get just a little logo, okay, just a little button. And if you click on it, it opens your Windows Explorer where you can then go find your file. So you would go to your documents, go to your ID files, go to your Inventor projects, go to your miscellaneous kind of Inventor practice, and then I should see all my files. And I am, again, going to make sure that I upload the snip, which is a picture file. It's a PNG file. I don't want to upload the Inventor file. Okay, so I'm going to choose that. I'm going to upload. It attaches it, and then you have to hit add or submit, click whatever it says on yours. So, all right, I'm going to hit cancel, and good luck with that.